All right, so we're going to dive into something pretty cool today.
Yeah.
Thermal imaging. Ever heard of it?
Oh, absolutely. Yeah. Fascinating stuff.
Yeah, it's like, being able to see heat instead of light. Yeah.
Exactly. Yeah. It's like having a superpower almost.
It's like a sixth sense, right?
Totally.
So we've got this tech article here, and it really goes deep into how thermal imaging works,
hmm
all the different ways engineers use it, and even some of the limitations.
I think a lot of people, when they first hear thermal imaging, they think, oh, like night vision goggles or like, those Predator movies or whatever.
Yeah.
But it's so much more than that.
Right. And this article, it doesn't even just like scratch the surface. It really
Mhm.
gets into the nitty-gritty.
Yeah.
But, for someone like me, who's, not an engineer, I was really struck by how they use it to analyze engines, like car engines,
Oh, yeah.
to design them better and make them more efficient.
Yeah. I mean, you can see like where the hot spots are, right? Where the
Yeah.
engine's not cooling properly.
Exactly. And it's not just about like fixing problems. It's about optimizing the whole design,
Yeah.
like from the ground up.
Absolutely. It's an incredibly powerful tool for engineers.
Yeah. I mean, the article even talks about how they're using it for like electric vehicles too,
Oh, yeah.
which I thought was really interesting because, with electric vehicles, battery management is everything.
Right.
Keeping those batteries at the right temperature.
Crucial, yeah.
Yeah.
So thermal imaging, I mean, you can monitor the entire battery pack,
Wow.
in real time so you can see if there's any hot spots developing or any areas that aren't cooling properly. And that can help, prevent damage,
Yeah.
extend the battery life.
That's amazing. So I'm curious though, like how detailed can these thermal images get? The article mentioned something called thermal maps. Is that like kind of like a heat map?
Yeah, exactly.
All right.
Like, you might see on a weather report,
Yeah.
different colors represent different temperatures.
Right, right.
And, the cameras themselves, they come in all sorts of different types with varying levels of sensitivity
Okay.
and detail. Some use cooled detectors for extreme precision.
Right.
Others are uncooled, makes them more portable and affordable.
Oh, interesting. So speaking of affordable, the article mentioned using thermal imaging on production lines.
Yeah.
So is this something that only big manufacturers can use? Or, can smaller businesses benefit from this technology too?
Well, you're right. The high-end systems, they can be quite expensive, but there are more and more affordable options becoming available all the time.
Oh, really?
Yeah, you can even find thermal imaging attachments for smartphones these days.
Wow. So it really is becoming accessible to, even individuals.
Absolutely.
That's incredible. Okay, so we've got these colorful maps, but the article kept talking about infrared radiation. Can you break that down a bit?
Yeah.
How does a camera even, like, detect that and turn it into a visual image?
So basically, every object emits infrared radiation. The hotter the object, the more intense that radiation is.
Makes sense.
So the camera has special sensors that can pick up this radiation,
Uh-huh.
convert it into electrical signals,
I see.
and then those signals are processed to create the thermal image that we see.
So it's basically translating the intensity of the radiation
Exactly.
into different colors.
Yeah, that's right.
Okay, that's really cool. So there's this term in the article that I was curious about, dynamic testing.
Oh, right. Yeah.
What exactly is that? And how is it different from just like taking a picture of a stationary object?
So dynamic testing basically is when you're capturing thermal images of an object while it's in motion
Oh.
or while it's operating. And it's really useful because it can reveal issues that you might not see in a static image.
Makes sense.
For example, you could see how an engine heats up under load or identify any friction points in a moving assembly line.
So it's like seeing the heat change over time.
Exactly.
Yeah. Okay, that makes sense. So the article also mentioned some limitations of thermal imaging. Like it can't see through solid objects.
Yeah.
Why is that?
Well, think of it this way. It's capturing the heat that's radiating from the surface of an object. And, infrared radiation, kind of like light,
Yeah.
it can be absorbed or reflected by different materials. So
Wow.
solid objects, they tend to absorb or reflect most of that infrared radiation.
So it can't penetrate through like a wall or something.
No, not really. It's really seeing the surface temperature.
Okay.
And, it's also important to remember that, the material itself, how well it emits thermal radiation can also affect the accuracy of those readings.
Right. So we've talked about engines, we talked about production lines, but what are some other ways that this technology is being used, like some more surprising applications?
Well, one area where it's really making a big impact is in healthcare.
Oh, really?
Yeah. For example, it can be used to detect inflammation,
Wow.
assess blood flow, and even aid in the early diagnosis of certain conditions.
So you can actually see, like, differences in temperature within the body.
Absolutely. It's pretty remarkable. And it's also becoming increasingly popular in building inspections, to identify insulation problems,
Oh, right.
air leaks, moisture buildup.
So many applications.
Yeah,
It's amazing.
absolutely. I think as the technology becomes more and more affordable and accessible, we're going to see even more innovative applications emerge.
It really does make you think, like, what else could we use this for?
Oh, absolutely. Yeah,
It's exciting.
it is.
So to wrap things up, thermal imaging allows us to see the world of heat. You know, it's providing these incredible insights into everything from how efficient our engines are to like potential health problems.
Yeah,
And it's
yeah,
really changing the way we design things, build things, even heal.
absolutely. It's a powerful tool. And it makes you wonder, we've talked about all these practical uses, but what about the artistic potential?
Oh, interesting.
Imagine using thermal imaging to create art, to capture the world in a totally different light. Or heat, I guess, in this case.
It's like a whole new way of seeing the world.
Exactly. The possibilities are endless.
Well, that's definitely something to think about. Thanks so much for, breaking all this down for us.
My pleasure.
I think we've all learned a lot today. And, to our listeners out there, we hope this deep dive has sparked your curiosity about the unseen world of heat.
Absolutely.
Until next time.
See you then.